Okay, in our next example, we have these three equations, and we have three variables. This time we're using x, y, and z instead of x1, x2, x3, but it doesn't matter. You could use any three letters you wanted to for the variables. And let's call this equation 1, 2, and 3. Just give them names so we can refer to them. All right, well, notice that if we were to add any of these two equations together, we wouldn't be able to eliminate a variable. But we could, if we wanted to, subtract equation 1 from 2, and we would eliminate the x. But I'm going to do it this way. I'm going to choose, it would be just as easy to eliminate an x or a y or a z from two of the equations. But I'm going to take this. I like to start with a variable that has a coefficient of 1, like this x right here. And notice that if I were to take that equation and multiply it by -2, I would have a -2x. And then I could add that equation to equation 1 and eliminate an x, this x term. And I could also add this -2x equation into equation 2 and eliminate that x term. And that would give us two new equations that have only y and z in them. And then we'll solve those like we did in the previous section. So let me just make a note right now that -2 times equation number 3 would be as follows. -2x minus 2y minus 4z equals -18. We're going to use this. And we're going to add this equation, which is a multiple of equation 3. We're going to add it into equation 1, and we're also going to add it into equation 2. So let's do equation 1 first. Equation 1, I'm just going to write it exactly as it is. And then I'm going to write this -2 times equation number 3 right below it. -2x minus 2y minus 4z equals -18. So now when I add these two equations together, that becomes 0. So we're eliminating the x variable. So when I add these, I'm going to get a 2y. We have 2z and -4z, so -2z. And then when you add 6 and -18, you get a -12. So now we have obtained one new equation that has only two variables in it. And if you wanted to, you could call this, you could give it a name if you want to. We could call that equation 4. So now we have 1, 2, 3, and here's a new equation 4. Let's do similar, where now we're going to take equation 2 and just write it exactly like it is. 2x plus y plus z equals 16. And let's do the same second equation, -2 times equation 3. We're just taking that from upstairs right up here. -2x, -2y, -4z equals -18. And once again, we're going to get the variable x term is going to be eliminated. So let's add y and -2y to get -y. We've got a z and -4z. That'll be a -3z equals 16 minus 18 is -2. That's a new equation. We'll call that, I have to write it over here on the left, we'll call that equation 5. Well, notice equations 4 and 5 are both linear equations with exactly two variables, and they're the very same variables, y and z. So we can solve them very simply as we did in the previous section. So let me write down equation number 4 again. Just like it is up there. So that's equation 4. And what would I have to do to eliminate the y? If I have a 2y here, equation 5 has a negative 1y here. If I were to double equation 5, I would get a negative 2y. So when I write it underneath here, I'd have a 2y and a negative 2y, and they would cancel each other out. So I'm going to write 2 times equation 5, which would give us negative 2y minus 6z equals negative 4. Okay. Now when we add them together, look what vanishes. We're eliminating the variable y, so we simply get negative 8z when we add these two together equals negative 12, and negative 4 is negative 16. So if we divide both sides by negative 8, that cancels, and we get z equals 2. So that's one of the 3 variables that we need to solve for. So let's go back to either one of these equations, equation 4 or equation 5, which I also have written here. And let's, I guess I'll just take equation number 5. Let's rewrite 5 with z. Instead of z, we'll write a 2. So I will have negative y minus 3 times z, which is 2. That's a 2 now, not a z, equals negative 2. So that's like saying negative y minus 6 equals negative 2. Adding 6 to both sides, get negative y equals negative 2 and 6 is 4. Well, if negative y equals positive 4, multiply both sides by negative 1, we would get y equals negative 4. Okay, so we're 2/3 done. We've solved for z, we've solved for y. Now we have to go back to any equation on this paper that has x, y, and z in it. We could use this. Let's go back to one of the originals. And maybe we'll do equation number 3. Equation number 3 is, let me write it again. It's x plus y plus 2z equals 9. I just copied it from right up here. X plus y plus 2z is 9. Okay, so that gives us x plus y is a negative 4. So I could have written x minus 4 plus 2z, which would be 2 times 2, because z is equal to 2, equals 9. So this is the same as x. This is a negative 4 plus 4. Oh, this is 0 right here. So x equals 9. Didn't have to write them that far apart. So the way we would write this is x, y, z. X is a 9. Y is a negative 4. Z is a 2. This is the ordered triple that gives us the solution. X equals 9, y equals negative 4, z equals 2. If you plug it into all 3 of these equations, you'll get a true statement. So this is the solution to all 3. It's a solution to all of them. It is the one single solution to the entire system of equations. And before we go on this video, I just briefly want to say, geometrically speaking, what we're doing here. When you have an equation like number 4 or an equation like number 5, it's a linear equation in 2 variables. So if you were to graph it, it'd be a straight line. Here we have 3 variables. linear equation in 3 variables. When you graph this equation number 1, it turns out to be a plane. When you graph number 2, it's a plane. When you graph number 3, it's a plane as well. So you could think of it almost like perhaps one of these would be a wall in the room you're in right now. And this next one could be a wall that touches it. So they meet at a line. And then this could be the floor or the ceiling, but we'll say it's the floor. What points are in all 3 of those planes? There is only one. It's the corner point on the floor where the 2 walls meet. And essentially, this is what we found. This is the one single point where all 3 of these planes intersect or meet.